Today you are working on activity 2.1.3, which is going to be a box assembly and a jack screw assembly. Very similar to the jack screw that we watched yesterday on the Alaska Airlines flight. So you have your sheet of paper, which shows you how the different pieces belong together. And on Google Classroom, click on the first link, the link that's called Box Parts. And when you do, it's going to bring you to a screen that looks like this. And you can't do anything until you click Sign In. So you do have to sign into OnShape. Once you are signed in, you still can't do anything because it's view only, but if you click on the blue Make a Copy to Edit button, now this will be your copy of the document. So go ahead and put your initials in there or your name or something like that, and it is going to copy the workspace for you. So everything that was in that file is now yours that you can work on. So at the bottom there are three different tabs. We have the top-bottom tab with the top-bottom piece built. We have the side piece in a specific orientation because we want to build our box in this exact same placement. And then lastly, the back piece of the box is there as well. So the front is open. It's an open front box, and there are only 5 parts to it. So for us to be able to put these individual parts together, it is going to be in an assembly. That's what this entire unit is for. So on the plus sign to insert a new element, choose Create Assembly. And that'll bring up a new tab. And right off the bat, there's nothing in here. It also doesn't have the planes because it's not a place to build parts. It's a place to bring parts that have already been built. So up in the top left, go ahead and click on Insert, and it should bring up the part studios from this very file that you're in. So that's one really nice thing about OnShape. If you're in the same file, they're all here. So let's go ahead and bring in the back piece. There it is. Let's go ahead and bring in the side piece. And I'm going to click once, and I'm going to choose the side piece again because we need 2 sides. And lastly, the top-bottom piece, we need 2 of those as well. So you can place them wherever you want. And click the green check. So the best part about OnShape is the fact that you don't have to build a part twice. You just bring it into the assembly twice. It's the same identical part. So that is really good to work with. You'll also notice that there is an origin point. You can end up setting something on that origin if you want. It's kind of up to you. It's not nearly as necessary in this space as it is in parts. However, when you do select a specific view from the view cube, it does tend to kind of center around that. So it's good to make sure to keep your parts kind of, near it. So let's go over the different types of mates that exist. So putting things together, it's kind of like deciding how things are going to get glued or attached. And there are different degrees of freedom that exist in 3D modeling space. Things that slide forward and backward along an axis, that's a degree of freedom. Things that slide up and down, and things that slide left to right. So those are 3 degrees of freedom that exists along the 3 main axes. And then the other 3 degrees of freedom involve rotating around those 3 same axes. So it's trying to work out, okay, what do we want this part to do? Do we want it to be stuck and fixed? Or do we want it to be able to slide in and out? Do we want it to also rotate while it slides in and out? Those are the kinds of things that we have to think about. And so up in the kind of left edge here, this is where our mates exist. So we've got a fastened mate. This removes all degrees of freedom between parts. So it's going to absolutely stick it down, completely glued. There will be no movement. The one next to it is a revolute mate. And this, allows it to rotate about just one axis. So it's only going to spin. That's all that it will do. The slider mate is a mate that allows translation or shifting along one axis only. So it will be able to move up and down or left and right or back and forth. But that's all it can do. The planar mate is a way to get two things to kind of stick together, but can still translate across the plane in multiple directions. So it restricts rotation, but still allows it to slide in, well, essentially two different directions, like on a two-dimensional plane. The cylindrical mate is an important one because we use this a lot for screws because it allows it to rotate and translate about an axis. So that's definitely one you'll want to keep in mind for the jack screw. The pin slot mate, we won't use this nearly as much. It allows it to translate along the center path of a slot. So we really won't do as much with that. There's also a ball mate that, well, allows a part to rotate over all three axes. So I'm thinking of, something that needs to rotate or spin in any direction, like a gyro type thing. And then parallel mate, parts can translate freely and rotate parallel to one another. We may not necessarily use that one as much because we don't often want something to be rotating while it's also sliding, at least not in the same way as what we would want for a screw, for example, for the cylindrical mate. So one important thing to do anytime you get started with an assembly is to pick a part, any part that you want for it to stay stuck down. Like for instance, the bottom of this box, I'm going to right click on the box and choose Fix because I don't want anything to move. Once I start putting this together, I need it to stay put. And I want all my other parts to be able to go and sit on it. Okay? So keeping in mind that when we assemble something, we are not just getting the parts to kind of sit on each other and look nice. Okay? That is not correct engineering actions for assembly. What we have to do is restrict the degrees of freedom by actually applying these different mates. So one really nice thing about OnShape compared to some other programs is that if I decide something needs to stay stuck, all it takes is one mate, the fastened mate. So because I don't want the parts of my box to move, I'm going to go to this bottom face and select one of these points. So these are called mate connectors. I'm going to select this back corner and notice that it's oriented down because I'm dealing with this bottom face. Okay, I'm going to click on that back connector, and now where that should attach based on our picture is on the top of our base, and we've got to make sure that it's oriented the same way. Yep, that it's facing up, that these are going to come together this way. Let's go ahead and click there. It gives you a preview. You can still undo it if you need to. So if it didn't work out, click the red X, and that way you can start over. But to me, this looks really good. If you want to make sure that it's not going to go anywhere, click Animate Degrees of Freedom. It's not going anywhere. And then click the green check. So to test, I can click on the side and drag it. It's not going anywhere. The bottom piece already won't move anywhere because it's fixed. That icon comes up, it's already fixed. Okay. So the goal is to be able to go around and mate all of these parts together in this orientation. So this other side piece, if I use the bottom, once again I'll need that bottom face, and I'll need a corner on the outside to stick to the base of this box. So it's going to be another fastened mate. Let's go ahead and select that. And you can pick them in any order. It doesn't have to be the side first. You can pick the bottom piece first and then come down here. Make sure that it's pointing down to match up with the one that was pointing up, and click the green check. And if you click the green check on the small dialog box, it leaves us with another fastened mate. And so if you have more to do, great. If not, you can always X out of there and it disappears from the browser. So the other top bottom, I can go ahead and set this right on top. It's another fastened mate. So I'm going to set it right on top here. So I'm going to go ahead and do another, far corner piece, that one that's pointing up there. Flip this around. And once again, I want that to be pointing down since it's going to come down from the top. Make sure that it's all lined up. If it's not, click the red X and it'll take it away. So you can try again or choose some different mating points, you know, whatever you might need. Because it takes a little while. You have to do a lot of zooming in to make sure that you're on the correct face, that the icon is pointing the correct direction. So yeah, get used to zooming in and out. If you want to use a mouse, definitely use a mouse. Yeah, I've got more mates to do. So this back piece ends up getting placed inside the box. So you can see how, okay, if we want it to be flush, it's going to have to sit inside the box. In fact, we can't really see that necessarily super well from the, because it doesn't show us a back view, but it is resting inside there. So we're going to have to be a little clever with how we choose to get that back piece placed in there real nice. So we're going to have to pay attention to our points. So I might choose that one. So pointing, and then this left edge because I want it to sit inside. So let's see if that worked out. Yeah. Okay, so that's nice and flush. That's exactly what I wanted it to be. So green check on that one. Rotate it around. Make sure that it's nice and flush back there. If at some point you realize, oh, I have a bad mate and I want to get rid of it, but you know the boxes have already gone away, the dialogues have already gone away, you can identify it here. It shows you exactly where you made the attachment point, and you can right-click and delete it. Now, the part didn't move, but you can then move it. So that is possible to get rid of a mate that way. Sometimes the undos and the redos don't work so well when it comes to these mates, so it's something to kind of keep an eye on. All right, so your assembly for the box is done. Now, if you go back to Google Classroom and you click on the second link, the second link is going to open up a jack screw scenario or a jack lift scenario. There will be 3 parts involved in it. I also need to click the link. This time, when you click on the link, you should already be signed in, and so that you don't have to sign in again. But you will still need to click Make a Copy to edit. So once again, go ahead and put your initials in there or something like that. All right, so we have a wedge, we have the wedge screw, right? So, okay, it doesn't have any threads. It should. OnShape is a little funny about threads, but here's what we want. We want this to actually screw into something. We want it to be able to go in and out and also to rotate. And then we also have a base piece. So this is the bottom of it. And then there's a folder here that says, no, don't click. If you do, okay, some weird things happen, and then you might be like, oh, well, now what do I do? And then you get like some weird things. So if you accidentally clicked on the thing that says, no, don't click, just click the home icon and click back to these parts. Okay. So that happens anytime there's like an upload of a separate file. So clearly I did not build these parts. Okay, so once again, we have these 3 individual parts. We want to create an assembly. So add an assembly in there. You can drag these tabs around and put them wherever you want. And the instructions say to insert the parts in the assembly, and I want to just fix the base. You don't have to fix it to the origin unless you just want to, but just kind of make sure they're around it. That's fine. So if you already know how to do that, pause the video and insert the 3 parts. So you might be wondering, where's the 3rd part? I am also wondering that. I have a wedge. I have a wedge screw. Where's my base? Because that is the current document I'm in. Go ahead and click Surfaces. Ah, yeah, there's a base. Okay, great. They are in there. says apply, oh, well, we didn't fix the base yet. So let's go ahead and right click and choose fix. Now it is stuck down. Apply appropriate constraints so that the wedge top doesn't move on the base. So the wedge is going to stay down. So these are not oriented in the same direction, so you might have to kind of think about how you would treat this to try to get this to stay put. Now, if you left click once on an item, you can rotate it in this space to help just kind of picture it or help think about it. And that can certainly be a little helpful as you are picturing what mating points need to go down. So to make something stay put, that's our fastened mate, that very first mate. So we use that a lot here recently. The thing to watch out for is that when you zoom in, there are lots of attachment points, lots of mating connectors that are available. So try to remember which one you picked so that when you select your second surface, you know which one you chose. Check out the, yeah, it looks really good. The preview looked good, so I green checked on it. And now, all right, so the screw is supposed to go through there and rest here. Okay, so let's take a look. Apply appropriate constraints so that the wedge screw stays in place on its round holder, but is still able to rotate freely through the hole on the wedge. Okay, so looking at the picture that they provided us, we can see kind of how it's resting. Okay, but we do actually want it to stay put. We don't want it to go in and out. We're going to need it to stay put. We just want it to rotate. So if we just want rotation, Revolute Mate is the place to go. So for revolution type things, sometimes it's easier to select a circular so that we can select a center, basically an axis of rotation. So I'm going to just select any circular face on there. And I'm going to use this hole. So this looks really pretty good, at least for alignment of getting it into the hole. If for some reason something is oriented funny, or it's, the head of the bolt is the wrong direction, there are some flips that you can apply, okay, that can help you. There's also a reorienting a secondary axis if that's something that is an issue. So you got a couple options there. Okay, so it is rotating. We can see that based on the head of the bolt, but I'm not able to move it to place it somewhere else. So I'm going to delete the Revolute because I think maybe we need to rest it a little differently first, to rest it in there and see if we can't make this place itself a little bit better. So instead of selecting the surface I chose, I think I'm going to try to get this bolt head basically to nest right there. So same one, the Revolute Mate. It locks everything else down. All it can do is rotate. So let's try this. And there. Okay, so from what I can tell, I missed the hole, so I don't want that. Okay, so we need to try a different approach. But that was the only option that it gave me. Okay, so not loving the options that I had, so I'm gonna need to try a different look. All right, let's try that and the hole. How's this looking? But it's a little off of where it needs to be. So if you find out that, like, okay, I've tried a couple things, I can't seem to make this line up in quite the right way, but now at least it's going through the hole, there is an option called offset. So you can offset a rotation or you can offset a specific distance. And the z-axis is going this direction. And yeah, if we offset this, let's try 0.1 inch. Press enter once and it'll show you rendering. Okay, that's close. Let's try 0.2 inches. Okay, that's looking really pretty good, although that might almost be touching. 0.22. That gives us a little gap. Let's try 0.21 and enter. Okay, this looks really pretty good. Okay, so yes, we did a little tinkering with the offset to make this happen, but our bolt of the head of the bolt does rotate, so it's looking good there. It's going through the center hole. All right, so everything looks good. So offsets can be very helpful when, perhaps the mating points, we just need an adjustment from them. So number 4 wants us to perform an interference analysis between the wedge and the wedge screw components. So this is actually a pretty handy little thing. On the far right of your screen, there are a few options. One of them says configuration panel. That's not it. Nope, we want that to go away. Click on that again. Here it is. I knew it was on the right somewhere. It's this drop down about camera and render options. So, yep, we're looking at it shaded. That looks fine. Interference detection is one item right in this view and rendering. So go ahead and click on interference detection, and instances to analyze is in blue. So go ahead and click on the screw and then the top part of the wedge, and it will show you where the interference is occurring. So an interference fit, remember, that's where there's either going to be some force or some pressure needing applied because of the sizing. So if there is a screw involved that we want to, wind and screw so that something will lift, we do want there to be interference there. That is desirable. So that's good. Anything in red that's supposed to be red is a good thing. Now, the other one I'm curious about is between the screw and this base part, because we weren't sure where to set it exactly. So let's see if we have anything interfering between the screw. Oh, it will not let me select what it's sitting in. Okay, well, we're going to assume that it's fine. Surely that's not because it was a fixed. We can unfix something. Yeah, it won't let us pick that no matter what. Okay. All right. Oh, that might be because it's a surface. That's a possibility. Okay, so I'm not too worried about it, but that is one very helpful detection that we can choose just to make sure that things are sitting together properly or impacting one another in a correct manner. Okay, so that's a lot. We did a lot today with a couple of different kinds of mates. Tomorrow, when you come, we will be putting together a selfie stick. So it's got, the extendable telescoping rod. It's got some rotating parts because we want to make sure we know how to use some of these key features of assemblies. And the selfie stick has a lot more parts in it. So it's going to be a little more interesting than just the standard, we've got 3 parts here, or just all fixed mates. Okay, that is all for today. Thank you for watching this very long video, and I will hopefully see you tomorrow and hopefully be feeling better. Have a great rest of your day. Enjoy.